True. Always true. True. Always true.
Good evening, or good afternoon, I suppose now. How are you guys doing today? Because I'm recovering. I hope you guys are feeling well. I'm certainly doing okay. Let me see. Boom, there we go. All right, so I looked at the lesson for today, and today's C++ chapter is extremely short compared to most of the other ones. This one is chapter 12, getting things out of functions. It goes from 16:03:20 to 16:32:35, so it's slightly less than half an hour long. So depending on how much practical stuff there is for me to do, this might be a less than hour long stream, but it could also be probably as long as an hour and a half. What are you meowing at, dude? I was here for like 15 minutes and you were quiet, and then I came outside and now you're meowing at me. Silly little guy. Anyways, so I woke up extremely late today, but I'm feeling up to a stream, so we're gonna go ahead and get myself organized a little bit here. I need to create a few more I need to create a few copies of folders. Okay. Let me rename a few of these, and then we will be right on our way. Because my... because I was late to get out of bed when I could have very quickly just hopped out of bed and done this, but I didn't. So now I'm paying the consequences and doing it this way. You're gay. I don't know why I said that. I've been drinking. Sit down, you're gay. I've been having a good time. It was your birthday recently, right, Lazy? There we go. And then we can put the content of this one in here. Or is it like actually just today? It's today. Nice. Happy birthday to you. You live in a zoo. You look like a monkey. And you smell like one too. There we go. I celebrated it 2 days ago. Nice. Nice. Put on all these default. My template project folders inside of all my shiznit. And then once I can open folder, and we will be on project 30. Look at that. Okay, I'm set up now. I am finally actually ready to stream. Look at that. And let's... Alright, so like I said, this is probably going to be a pretty short one. We may not even go for a full hour. We'll see. Depends on how much practical stuff there is, how many questions I have, how easily I understand certain topics. But seeing as this is a continuation on functions, I'm fairly confident it'll be okay. Let's get into it, shall we? Boom, code scene. Fucking, what are we doing? Oh, it's on the wrong one. There we go. There we go. All right. Take it away, Gakwaya Sensei.
Passing parameters by value a few lectures back. I would like to welcome you in this new chapter where we will be focusing on how to get data out of functions. Again, the model of a function is really what you see here. It is like a machine, and you can give input to that machine and you expect to get something out of that machine. This chapter is going to focus on this part here, and we're going to see the different facilities offered by the C++ programming language to get output from functions.
There's a lot of different outputs you can get, right? Like an insane, like anything a computer can do is an output.
Go ahead and finish up here and meet me there.
Okay.
In this lecture, we're going to see how we can use function parameters to get data out of the function.
All right.
Here is a simple example, and we have three functions here. We have maxstr, maxint, and maxdouble. And you notice that we have three parameters for each of these functions. The first two parameters are going to be input. They are going to get data in the function. And the third one is going to be the output parameter, and it is going to get data out of the function. Let's focus on maxstr.
I'm just outside laser engraving. The stench is legendary.
The idea here is that for the third parameter,
I've never had a laser engraving. I've never been to a facility where they do it. Is it like actually that smelly?
The changes we do inside the function are also
veggie. Hello, Tara.
On the outside.
Lazy is celebrating his birthday.
Left out the
he celebrated his birthday.
That we have on the other parameters because we want to be able to modify the output variable here inside the function. If we marked the third parameter as const, we would get a compiler error if we try to do something like this and assign something to the output parameter here. So the main purpose of this function is to compute the maximum between these two strings. We are going to say if input
when I get a Discord, you'll show images.
Input 2, then input 1 is going to be our maximum, and we are going to store that in our output parameter here. If input 1 is not greater than input 2, then input 2 is our maximum. We're going to store that in our output, and whoever has access to input 2 outside the function is going to see the changes that we are making in the body of the function. This is really the technique we can use to send output from the function and make it visible when the function has returned. And again,
I won't distract you too much. No worries, man.
We set up the function in a way that the changes we do inside the function are going to be visible on the outside. And we are able to do that because output here is a reference. This is really key. We have used
Ah.
references
Oh
here,
God, he's
but we
putting it
can
on the
set up
left
the same
again. That's
thing using
weirding
pointers.
me out.
Because we have seen that with pointers, we can also make our changes inside the function visible to the outside. The two other examples here are really extensions of the same thing. We have two input variables, input 1 and input 2, and output is going to store the output from the function. You notice that output is a reference, and because of this, the changes we do in here are going to be visible when
I
this
guess it
function
makes
has been turned.
sense, kind
And
of.
we do exactly the same thing on max double
Yeah,
here,
left
but you
probably
see
makes
that
more
it is
sense.
using a pointer. Okay, I really wanted you to see this. So inside, we're going to try and figure out who is the maximum, and if input 1 is the maximum, we're going to write that in our output variable here. And you notice that we are dereferencing here because this guy is a pointer. And if input 2 is our maximum,
address, right?
we're going to write that in our output variable here. One thing I don't think I explained here is that we have a const std string reference here for max str. And the reason is that the input variables aren't really meant to be changed. That's why we mark them as const. And if you want to modify them in some way, you can take the const away and it is going to work. Okay, this is really the big idea we are playing with in this lecture, using function parameters as a way to output data from the function. And here are a few ideas you should keep in mind. Output parameters should be passed in such a way that you can modify the arguments from the inside the functions. And we have seen that we have two ways to do that. We could either use references or even use pointers.
27, baby, in my early 20s
what
arc.
you should prefer in modern
Oh,
C++.
man.
Input parameters
late 20s, big dog. Late 20s.
Just get data in the function, and that's why in most
Forever
cases
19.
you're going to see that they are marked const. Okay, now that we have seen all these ideas, I think it is time we headed over to Visual Studio Code and actually played with them. Okay,
Yes.
Here we are in our working folder. The current project is input and output parameters. We are going to grab our template files like we always do. We're going to put them in place, and we are going to open this guy in Visual Studio Code. We're going to just drag it and drop on top of Visual Studio Code here, and it is going to open up. We have our main function here. We can close the pane here and clean the file up a little bit. We're going to remove what we don't need here, and we're going to have a bare main function we can play with here. The first thing we're going to do is to put in our maxstr function. It is nothing special. We just have two input parameters and one output parameter. The output parameter is going to be what we use to get output outside the function. And inside, we're just going to compute the maximum. If input 1 is the maximum, we're going to write that in our output parameter. If input 2 happens to be our maximum, we're going to write that in our output parameter.
All right, let me get this shit written in. Okay, so void max str const std string address input 1 const std string input 2, and then this one is std string address output. And it looks like, oh, that's weird. If input 1 is greater than input 2, I don't know why I put a space there. Stop that. I'm like typing the wrong things because I'm a silly Billy. Then output equals input 1 else output equals input 2. Cat also wants to code. Is the cat meowing? The cat's meow. Meow. Look at all these dots. All right. So is my shit the same as his shit? It looks like it. Void max string const std string. It's a const string. Address input 1. So this is a reference. This is a reference to a const string by the look of it. I don't think we've used many const strings. This one is just a const string. This one is not an address. Huh. I'm a little bit unsure of what exactly this is, because what it looks like is that this is a const string, or this is const string, but it's a reference in memory to something called input 1. And I'm not 100% on. He has his thing like this, which weirds me out. I don't know. I don't think I like that. All right. Then we have our int main. All right. I think our stuff looks the same as his for now. Let's keep going.
Because our output parameter is a reference, the changes we make inside the function are going to be visible on the outside because we will be working on the original variable through the reference, which is really a true alias here. Okay, now that we have the function set up like
that
this,
makes
we can
sense.
head in the main function and try it out. We're going to set up 3 variables of type std string. I think we should include the string library here. Let's do that. And we're going to have an out string, which is going to be our output variable. And we have 2 input strings. One is initialized with Alabama, the other is initialized with Bellevue, and we're going to call our maxstr function here. You notice that it's not going to be using the return mechanism. We're going to be grabbing the output from this function using an output parameter, which is going to be our outstr variable here. Okay, once the function is done, we're going to have the maximum stored in our outstr variable here, and we can print it out. Now that we have this set up, we can actually try and build this. We're going to use GCC. Let's do that. The build is good.
Okay, hold on. I'm almost there. I'm almost there. I need to also find the string library that he's using. I think it's just string, but I want to look at it and make sure, because I didn't catch it when he was explaining. Out string std end line. All right, so let's see if I can understand exactly. Is it a string? I think it's just that.
We can out here. We're going to function put string.
Go back a little bit.
Okay, now that we have the function 3 variables like this, we can head in the main function and try it out. We're going to set up 3 variables of type std string. I think we should include the string library here. Let's do that. And we're going to have an out string, which is going to be our output variable. And we have 2 input strings.
New terminal.
One is initialized with Alabama, the other is initialized with Bellevue, and we're going to call our maxstr function here. You notice that it's not going to be using the return mechanism. We're going to be grabbing the output from this function using an output parameter, which is going to be our outstr variable here. Okay, once the function is done, we're going to have the maximum stored in our outstr variable here, and we can print it out. Now that we have this set up, we can actually try and build this.
I'm kind of curious how this is gonna work at all, because this is a greater than function. This isn't numerical at all. I don't understand what exactly we're doing in this code. It's like a const string address, and our input 1 is this. Or it's this Alabama thing. And then this one is const string. This one's not an address. This is just string 2, Bellevue. And then our out string is essentially our output is going to be one of these two by the way this is written. I'm not 100% how this is supposed to work because I'm not sure what this does in the context of strings. Or strings and string references, I guess. That seems really weird.
We're going to use GCC. Let's do that. The build is good. We can bring up a terminal and clear and run rooster. Now you see that the maximum is going to be Bellevue. Let's try and change this to Casablanca. Why not? And we're going to see that the maximum now is going to be Casablanca, and our function is going to be smart enough to store the maximum in this output variable here. Let's build again. The build is going to be good. I'm going to clear and run rooster. Now the maximum is Casablanca. Hopefully you understand that we are able to make the changes in the function persist because our output parameter here is passed by reference. This is a true reference, and any change we do to the output parameter here is going to be visible in whatever variable you passed as an argument for this third argument here. This is what is making this work. Now that this is working, we're going to comment this out and
Okay. I understand what the point of the lesson is. Like I think I understand where the point is that it's like we can when you pass these things as a reference, or at least one of them as a reference, I'm not quite sure how is how do I formulate a question to answer the to the question that I'm really having? I think what I'm kind of confused about is what exactly these are doing. I remember this is as I don't know, with words. What do you mean with words? Debated sleeping in because of the suffering, but I must persist. You must. You must. I mean, I'm trying to think. How do I guess I do formulate my question with words. But how to ask the question that gives me the information that makes this click? So, const std string address. So does this mean that I can change? I should be able to change this one as well. So now this one should be Dover, I think, if I run this. Okay, so now Dover is our maximum. I'm curious what the difference is in function between these two. Why we've passed one as a reference and the other as a not. Literally no reason. They should both be references. I mean, I figure they should both be references because that's what that seemed to be the point he was getting across. Is that they like when you do it as a reference, then you can change stuff. You can change what these things are directly in the function. But what I'm kind of curious about is why it doesn't seem to matter in this situation. Because now I've changed both of the strings at some point, and it seems like it's done the same thing for both. Also, your ifs are too indented. It should be one indent, not four. What, like, just from here? Well, the output equals should be 2 indents. Shaking my damn head. Every curly brace is another indent. I mean, that makes sense. That's something I can follow. Lazy, you need to make a 32-hour tutorial. I'm telling you, it'll be funny. It would be kind of funny. I'd rather... I don't blame you. I hate the idea of... it's not that I hate the idea of, like, teaching someone something complicated. It just, like... If I can't, like, get my hands on you, on your face, and, like, grab you, it's like, I need you to pay attention to what I'm gonna tell you. Alright.
Put in another example for you to play with. The next function we're going to play with is going to be maxInt, as you see here.
Oh boy, maxInt.
It is very similar to our maxHDR, but you notice that our inputs are no longer references. Because we don't really mind copying fundamental types in C++, they are small in memory, so copying them is really cheap. We can pass them by value, and this is not going to be so wasteful in our program. But the first parameter must be passed by reference because we want to use it as an output parameter, and we're going to use it to get output from the function. And the way we're going to do that, we're going to write whatever variable is the maximum in our output parameter, and the changes are going to be visible on the outside. Now we are going to head over in our main function, set up a few variables, and play with us. So we're going to say int out int. This is going to be our output variable, and we're going to say input 1. Let's say in1, and we're going to initialize this with a 45. Why not? And we're going to say int in2, and we're going to initialize this with 23. Why not? Now that we have this, we're going to say maxInt, and we're going to put in our input. We're going to say in1 and in2. Then we're going to say outInt as our output variable. Now that we have this, we can actually print out whatever number is the maximum through an output statement like this. Really simple. We're going to say maxInt, and we're going to say outInt. That's where it is going to be stored, and we are able to do this because, again, the third parameter here is passed by reference, and any change we do in the function here is going to stick even when the function here has returned, and we're going to have that stored in our third parameter here. And this is a really common technique, especially in code that has to interface with C code out there from C++. And you really need to be aware of this. Now, if we run this program, we're going to see our maximum printed out, and it is going to be stored in our out variable here. Let's do that. We're going to use GCC to build. The build is good. You can clear and run Rooster, and you're going to see that the maximum is 45. If we...
All right, let me run task. I assume that this is correct. maxInt 45. Right, let me make sure so my integers are still the same. Okay, good.
You really need to be aware of this. Now, if we run this program, we're going to see our maximum printed out, and it is going to be stored in our out variable here. Let's do that. We're going to use GCC to build. The build is good. You can clear and run Rooster, and you're going to see that the maximum is 45. If we change and store our maximum in2 here, and for example, let's make this a 723. Let's build again to take the changes into account in our rooster.xe binary. We're going to clear and run Rooster, and you're going to see that that's the maximum here. We are able to grab whatever is the maximum from these two input parameters and store that in our output parameter here because we are passing that third guy as a reference. This is really important. We have seen that we can use references to make changes we do in the function stick and be visible and outside variables. But we can also use pointers, and I am going to show you an example of how we can do that. First, we're going to comment this out because we don't want noise output in our program, and we are going to go on top and set up a max double function which is going to grab our output using pointers. The name of
Okay. I guess one thing that I'm a little bit not clear on, I guess, is why we have this third parameter in our function. Like, I get that we're calling it output, which is like that kind of makes sense. I think this is like the main conceit of this section is we're creating a third argument that we're calling our output. And then in our in the body of our function we're using it, we're creating it here, I guess. It's awful. I don't know why he would teach you how to return values like that. Well, it's weird to me because he has done just return before. And like it was like basically like with at least with integers it was basically just return whatever is largest we've done already. And we've done that in the and since that's in the past, I'm kind of curious why it would be necessary to do that here. I don't know why the third argument is necessary when the function can do something else. Or like we can literally tell the function to just print out whatever other text. I'm kind of curious. It seems very it's not. I don't know. It seems unnecessary, I guess, is my kind of the feeling that I'm getting. And this one's a double pointer to a place called output. Or it's a pointer called output. I really... Alright, so then we do if input 1 is greater than input 2, our pointer to output equals input 1. Yeah, wait, I'm an idiot. Else output equals input 2. How it should be done. I just, it feels weird. And I think it's especially confusing with this example at the first one we did, because it's like we're using a greater than function with strings, which like fundamentally I'm understanding that what this means is that it's alphabetical, or rather lexicographical order. So like I'd assume that if I made this D lowercase, then probably, or if I made the C lowercase, then the D probably comes out first. Or if I used a number, that would probably come out before any letters, which is like it kind of makes sense, but it's also it's weird to use a greater than function for something using strings, I think. Like I think the point is just to demonstrate that how we're using the output. We're essentially assigning a value to output via the function and having that be what's returned. Return is how it should be done. I mean, yeah, that's the way, because that's the way we did it. We did it with some numbers before, and it makes sense. It's like, oh, this thing returns an integer. We just return we return whatever's greatest, and that makes sense. With strings, I think it's a little bit like I could kind of understand why you would want to do something like this, but I'm not really sure why we would use a greater than function specifically. Like it might just be because this is the shortest, simplest kind of function to make, and it's like okay, it demonstrates the point. But as an example, I found it very confusing.
The function is max double, it's not going to return anything, and it is going to take two input parameters, input 1 and input 2, and it is going to tell us whichever of these two is the maximum. The maximum is going to be stored in our output parameter, but we are using pointers to make the changes inside the body of the function stick and be visible on the outside of the function. So we are going to dereference here because the third guy here is a pointer, and we're going to store in whichever is the maximum, and when the function returns, the maximum is going to be visible on the outside. So let's go down and try this out. We're going to say double, out double, and we're going to set up our input here. We're going to...
All right, let me move this further down. And we will do double, out, double. Let me start this again.
Say in double 1, and we're going to make this 45.8. Why not? And we're going to do a second input parameter, and int, we should say in, not int. Sorry for this. In double for input double. So we're going to say double 2, and we're going to initialize this with 6.9, for example. We can really put in anything. Now that we have this, we can call our max double function. Let's do that. We're going to say max double. We're going to say in double 1 and in double 2. Let's do that. And we're going to have out double as our output parameter. And because it's a pointer, we need to pass this guy as an address. So we're going to say address of out double here. That's how we're going to be able to manipulate that inside the function here. Once we do this, we are going to have our maximum stored in out double, and we can print that out. So we're going to say stdc out max double, and we're going to say out double stdendl. And if we build, why do we have a squiggly line here? We don't have a semicolon at the end of our function called here. So we're going to build with GCC as always. You're going to see that the build is good. We can clear and run rooster. Max is 45.8. If we change and store our maximum and
Okay, well that just seems incorrect. Did I fuck up making this? Double 1, double 2. So if input 1 is less than input 2, then the address of output becomes input 1. Else the address, the thing stored at address of output, I should say. Oh, yeah. Yeah, have this reversed. That makes sense. So it should say 45. Let's try again. Make sure I didn't screw the pooch completely. All right, 45.8. There we go. There we go. Fucking hell.
in double 2 here, we can change this guy to 76.9. We're going to build and see that we are actually grabbing the maximum regardless of the variable in which it is stored. If we run rooster, we're going to have our maximum.
Okay.
This is working exactly.
It's amazing. I made one tiny mistake.
This is really all we set out to do in this lecture, showing you how you can use references to use parameters as output channels for data to get outside of the function and be used in variables that are outside the function here. I really hope this makes sense, and this is a technique you need to be aware of. We're going to see other techniques to do the same thing, and starting in the next lecture, we're going to see how we can return from functions. For now, I hope you found this lecture interesting. We are going to stop here in this one. In the next one, we're going to see how we can use the return mechanism to get data.
Okay, so we're going to cover
function.
return specifically on the next part.
Here and meet me there. In this lecture.
Okay, so I'm kind of curious why we're doing things in this order. Because we have done returning from functions before, but now we're covering returning functions specifically. The other thing, so I can kind of understand why you would want to do something like this. Why you'd want to have your an output value that is dereferenced, but it seems, I don't know, excessive in a way. It doesn't seem like it's all that necessary to do. Because like you especially with the integers, you can just return values, because I've done that already in this lesson, or not this lesson, in this course. I've returned values. So this is really, using references pointers instead of just returning can be useful when you want to return multiple variables at once. That makes sense. I wish he would have shown an example of that then. Something that returns multiple variables or multiple outputs, because this seems a little bit like maybe that's a little bit more complicated and a bit out of scope, but it seems very, like, the way that we've done it now, it seems a little bit like, okay, I know that this is a possible thing to do, but why? I don't understand why I would want to do it. You know, like I I don't think there's anything that I've been shown that I've been in this lesson, or in this entire course, where I'm like, okay, well, that has absolutely zero use cases. But there have been quite a few times where I've been like, okay, I know this is possible, but why? And if it is, and if I don't have that why, at least personally, I find it very difficult to call upon that information when it becomes relevant. You know, if I haven't seen an example of the thing working, I find it very difficult to be like, okay, well, then we can use this thing that I found out about, that I was told about. I don't know. All right, let's what am I doing? I'm just gonna, all right, we're gonna save this one, and we'll open another folder, I think.
Lecture, we're going to
All
see
right.
how we can get data outside of a function through the return mechanism. And this is going to be an alternative to the way we have been doing things in the last lecture, where we used function parameters as channels to get data outside the function. Let's look at a simple example of how this is done. Here we have a simple function called sum. The function is going to return int, and it is going to sum up two parameters that we pass to it, int a and int b. If we get inside the function, we're going to do something really simple. We're going to set up a new variable which is local to the function. We're going to call that result. It's going to be the same type as our input parameters. And we're going to add up a and b and store the result back in our result variable here. Once we have this, we're going to return this for this variable to be visible by whoever called this function here. One thing you should know is that this variable is local to this function here.
Yeah,
And
it doesn't
will
come
be
outside of it.
destroyed the moment we hit the end of the function here and the function terminates. So if we
Which
go in
seems
main
kind
here,
of
we're
like
going to
what
try
the
and
other
see an
one,
example
the
of how
last
we
one
can
was
call
trying
this
to
function.
avoid. It like
We have two
affects the stuff
variables,
outside
a
of the
and
function.
b, and we have a new result variable set up in the main function. Please note that this variable is very different from the variable we have in the sum function here, because they live in
Or
different
not
scopes.
not effects. What am I
Okay, we
saying?
are calling
It the one from before created an output value. I don't actually no. What does that? Can we hold that output value for something more outside? The way, because it was created as part of the function, and I imagine that it, unless we created another, unless we had it edit a variable outside of the function, I don't think that it would we wouldn't be able to use our output variable for anything, which was it was a pointer to I don't know. I just don't know. With the thing staying inside makes perfect sense because that's like okay, sure, and then something that directly edits an outside variable, I can kind of see, but I don't know if we can. I don't know if we can do. I just. I'm
Our
gonna keep
sum
watching.
function
Maybe
here,
I'll
and
be
we are
enlightened.
passing it two arguments in the form of a and b here. The function is going to compute our sum and it's going to return it, and we're going to store that back in our local variable to the main function here. The result variable here again is local to this main function. Okay, once we call this function, we're going to have our result stored in here, and if we print like we do here, we're going to see it printed out on the console. In this case, it's going to print 50 because 34 adding 16, that's going to be 50. But one thing I want you to know is that this is going to return by value. And what we mean by this is that we're going to copy whatever we return here and store a copy of that in this result variable that we have in the main function. And we're going to
Okay.
prove this. Notice the stdcout statement we have here. This is going to print the address of this local variable. And once the function terminates, we're going to try and print the address of this result variable in the local scope of the main function. And we're going to see two different addresses, and hopefully this is going to prove that we are returning a copy. It's not
Yeah,
the
because
original variable that we
it's
have
not
in
the
the
same
sum
one.
function
Because
here
we've seen
that
that
we are
before as well.
returning. Okay, hopefully this drives the point home that we can use the return mechanism to get data outside the function, and we're going to grab the result in our result variable here, and we're going to use it however we want in the main function. But things don't always work like this. Sometimes the compiler is going to insert optimizations and not really return by value. But returning by value is the default. But if the compiler notices that it can do things better, it is going to optimize your returns by value to return by reference. And you're not going to make a copy, but you're going to somehow reuse the local variable in the main function. Let's look at a simple example to really drive this home. We have a function here which is going to add strings. It is going to basically concatenate them using the plus operator here. And you notice that inside the function here, we're going to set up a local variable which is going to store our concatenated string here. And we're going to print the address of the local string. After that, we're going to return the string so that it is usable by whoever called this function. Let's go in main and see how we can use this function here. We are setting up a variable called strResult, which is going to store our result string. We are saying add strings here. We are calling our function, and we are passing in two strings, hello and world. And we want to concatenate these guys. This is going to give us our result, and if we print it out, we're going to get hello world printed out. But the main message here is that the address of the outside string here is going to be the same as the address we have on the inside here. And this is going to mean that the compiler has actually done some magic to return the local variable, because it has seen that we could really be wasting this guy here inside the function. When the function returns, this string result here is going to die off. But the compiler knows that we can reuse that and avoid the work of copying this string, which might be really large. Suppose this string has 1,000 characters inside, and copying it would be a waste. So the compiler is not going to return by value, which is the default. It is going to do some kind of return by reference. But it's really not a return by reference because this is a local variable. We can't really have a reference to a local variable to a function. That would be really bad because we might be able to modify it when the variable is actually dead after the function has returned. So it is some magic that the compiler is doing to
Magic
save you
is the
from
word for it, I
unnecessary
think.
copies, but you
'Cause
should
what
be
the
aware
hell?
of this and not make your code rely on returning by value. Okay, now that we know this, we're going to head over to Visual Studio Code and actually play with this. Here we are in our working folder. The current project is returning from functions by value. We're going to grab our template files pretty quick. We're going to copy them. Let's do that. And we're going to put them in the current lecture or project. And we're going to open this guy up in Visual Studio Code pretty quick. Let's do that. Now we have our main CPP file here. We can clean it up a little bit and close the left pane here because we don't need it. The first thing we're going to do is to put in our function, which is going to compute the sum of two integers and return us the sum of these two guys. Inside the function, we're going to set up a result variable, which is going to store the sum, and we're going to return it, and it is going to be visible to whoever has called this function here. Again, I am going to emphasize that this is going to return by value. So what we return is really going to be a copy of this variable here. And we're going to prove that by printing the address of this variable inside and outside the function here. So we're going to set up two variables in main. We're going to say int x. Let's call our input parameters x and y. We're going to put in a 5. And the second guy is going to be a y, and it's going to store a 9. Why not? After that, we're going to set up a variable which is going to store the result. Let's call this result, why not? And we're going to say sum x and y. Okay, we are passing these guys by value because we don't really care about copying an int. It is a fundamental type. It is really small in memory. So it's going to be very cheap to copy. It's not going to hurt the performance of our application. But what we want to do now is to print the address of the result variable in the main function here and see that it is the same as the address of the variable we have inside here. Another thing you should watch out for is that we are able to get data outside the function here. The sum was a local variable, but we are able to get it out of the function through the return mechanism here. Okay, before we go ahead and run this program, we're going to fix the statement here. We forgot to change this to say out to mean that it is outside the function here. That's the meaning. We're going to build with GCC. The build is good. We can clear and run Rooster. Now we're going to see that inside the function, the address of the result variable here ends in DAC, and outside the function, when we hit the end of the function here, we're going to see that the address ends in DE4. So this proves that the local variable inside the function and the outside variable here in the main function live in two different memory addresses. They are two different variables.
Two different things that have the same
And the return
name.
mechanism here is just going to copy whatever we have in the local variable and make it available on the outside here so that we can assign it to the result variable in our main function here.
Right.
This is how the return mechanism is working, and it is going to be returning by value by default. It is going to be making copies. This is the message here. Now that we know this, I want to show you that there are exceptions to that rule.
Oh,
if you return by
there are
value
exceptions.
like this, you won't be really always using separate memory addresses for the inside and the outside here. And we're going to prove that with a function that is going to add up two strings. Let's comment what we have out because we don't want this to confuse us. So we're going to bring this inside our block comment here. And we are going to go below our sum function here and set up a new function, which is going to be called add strings. It is going.
Okay, so this is going to be, this is a function that returns a string called add strings. And what we do is it takes an input of string type that we're calling string1 and another input of string type that we call string2. Std string. Now we create string result, which is supposed to be string1 plus string2, and it prints std cout in, and we're looking at the address of result. Std string and we're printing the address of result, which is also a string, std end line. I don't know why I did that twice. And then we return result. Yeah, so this is a string called result, which has a value that is equal to whatever our inputs are. In this case, I imagine he's going to go with hello world again. So we're gonna do when we do this, I think what it ends up doing is just int result, or not int. It'll be string result, I think. Yeah, because this is the yes. We'll create another thing called result. I imagine it'll be like string result equals add strings hello world, and then it'll print. We'll see. We'll see.
Going to
I'm
return
getting
a
ahead,
string
and
by
I'm not
value.
actually
Okay, it is
listening.
by value because this return
Need to
type here
listen.
is not qualified with anything like a pointer or a reference. So by default, it is going to be by value. And inside, you see we are doing the exact same thing we did in the sum function here. We are adding up
Yes,
two strings.
it is
We are
identical.
storing the result in a local variable, and we are returning that. But if we run this program, you're going to see that the address on the inside is going to be the same as the address on the outside. So let's set up something that we can play with here. We're going to go down in the main function and set up a few variables. We're going to say std string. We're going to say nstr1, and we're going to store in hello. Let's do that. And we're going to say std string nstr2, and we're going to store in world. By now, you know what I am trying to do here. I am trying to say hello world. Okay, once we have this, we're going to set up a result string. So we're going to say std string and say result str, and we're going to say add str, and we're going to add up in str1 and in str2. This is how we do this. And after we do this, we're going to print out the address of the variable here. So let's do that. And it is going to be the address of result str. Let's say that here. And we also need to print the actual result of this operation here. So let's do that. We're going to say stdcout result str. We're going to print the actual string. I don't think we did that on our sum function here, but we can quickly go there and prove that to you. So let's comment this out. Sorry for this. This is going to be confusing, but I don't want to leave you with unexplained things. So we're going to see that if we print this out, we're going to get the sum, which is 14 printed out. Let's do that pretty quick. We're going to go down and say stdcout and say result, and we're going to say result, and we're going to build pretty quick with GCC. And if we clear and run roster, we're going to see the result, which is 14 here. And you can change these guys up to really play with us. For example, if we make this 15 and put in
I didn't notice that we didn't do that. We were just because that wasn't the point.
Just to have fun with this, and we're going to clear
Printing
and
out
run roster.
this.
We're going to get a 24 here.
Yeah. Okay. We know that that's how that works. We know how addition works, and we know that the code works otherwise. This is. I mean, all this is here. I'll put it in here, and then it'll be we're just printing regular result, like so. There. But I'm more interested in this. So, essentially, what we've done, we have a string that we call in string 1 with the contents of hello, another string called in string 2 with the contents of world. Here, I could even make this neater. Do like that. Boom. Hello world. And then this one is also a string, and it's called result string, and what we want in it is the result of add strings, where we take this function and we put hello and world into these two functions, or into these two parameters. So hello and world are our arguments, and then we just add them together, which we learned about concatenation already. So it will just take them and put them like one after the other, and make them essentially just mash the strings together. And then it's and then what we have is a thing to print the address of this thing, this result, and return the result. And then when we do that, after we've done it, we have another thing printing the address here of result string, which is not the same as result. And then result string, and then we actually print the result string. So from what I understand, it sounded like what he was saying was that this result should be the same as this this address result should be the same as this result string. That's kind of my understanding of what he was telling me. I don't know if that's correct or accurate or what. We'll see. We'll see. Let's continue.
Now we can comment this back. I am happy I have showed you this, and we can uncomment our string code here and build and run it. So we're going to build with GCC. The build is good. We can clear and run Rooster. And again, what we want to see is that the compiler is going to optimize this out. It is not going to return by value like we had with the sum function, where we had the address on the inside different from the address on the outside.
Interesting.
You see here that inside, we forgot again to change this guy to out. Sorry for this. So we're going to make this guy out, and we're going to.
I mean, that doesn't really make a huge difference to me, but still.
And run Rooster. Now we're going to
because we understand that it's the same.
Inside the address ends in D30, and outside the address ends in D30. This can be really confusing because we said we wanted to return by value. By not decorating our return type with a pointer or a reference or something like that, it is going to be returning by value. And if you return by value, you're going to make copies. And if we made copies, the address on the inside and the address on the outside should be different, but they are the same. The reason is the compiler is going to notice that you are trying to copy strings, and it is going to see that the variable here, which is inside the function, is going to be wasted. When the function returns, by default, this should be really destroyed, and you should copy because you are returning by value. But the compiler is going to insert an optimization to do some magic and make it look like you are returning by reference, and it is really not going to
That's
make
really
it
interesting.
So it is going to reuse the address on the inside, and hopefully this
is
going
there
to prove this to
way
you.
to...
The message here is that you should...
I don't imagine that this has any actual... this, what I'm about to propose, has any actual use. Is there a way that you could turn that off? Like, is it... Like, I imagine... Like, I don't know why you would want to, but is that like a thing that you can actually change? It's like, hey, there's this compiler optimization that does this thing, and there's no real reason to ever want to turn it off. It's mostly a curiosity thing, I guess. Usually debug builds don't have optimizations like those. Really? Is there a particular reason why not? Let's continue.
Shouldn't rely on your functions returning by value, because if the compiler sees that it can do a better job than you, it is going to optimize your return by value to return by reference, and you're going to not be making copies. So don't make your code rely on returning by value and making copies, and you should be aware of these optimizations that the compiler can do behind your back. I would like to welcome...
Oh, hold on. I think that's the next chapter. Yeah, function overloading is the next chapter. That's also really short. Optimization obscures the code, so it's harder to step through it while debugging. Well, yeah, I can imagine if you were having some sort of issue with this particular thing, where for some reason you really wanted these two to be different places in memory, like, and the engine, or the fucking compiler having this optimization make it very like, what the hell, what's going on, I don't understand what the issue is. I mean, I don't know why, like, I don't know why you would want that. I don't. I am neophyte, but still, I think I think it's interesting to see how that all works. I feel like if you were doing this in the first place, you would probably be, because my understanding is that the reason that it does this is because it's more efficient, right? It's just there's no reason not to. I feel like it's one of those things where there's very few. It's like I think the term is like, it's like strictly more efficient and better to do it by just passing this as a. You'd probably want to. I'm thinking how to talk because I can't brain more gooder sometime. I feel like you could avoid having this be confusing if you passed it as a pointer, especially with these strings, right? Like with the integers, it was like, okay, well, this is small and effective anyways, it's not a big deal. With the strings, it's a little bit less effective, so maybe you would want to pass those by pointer or by reference yourself in the first place. Is kind of the way that it seems to me. The way that this lesson has made me understand the use and the efficiency. Ugh. Not gonna lie. This one's only This is only like 15 minutes. Yes, copying strings is relatively expensive, especially with STD strings, since the size is dynamic and requires heap allocations. Wait, this whole time this has been using the heap? Passing a string or reference is more optimal, but the return type being void and having useless input variable is hard to read in larger projects. I mean, yeah, I can when you say useless input variable, yeah, are you just do you just mean like having this stuff, or is there something more on there? Because I remember it was something that we could do where it would like shorten this. I don't know if it was like just don't have it at all. When you had STD string output. Oh, when you had the output thing in here, yeah. I didn't. Let me look at that again real quick, because this is the end of this lesson. But if we look back at this one, I don't know why having this in the output, or having this in our parameters feels very weird to me. Like all three of these feel very strange. It's like I'm not quite sure why we bothered with that, because you don't as far it didn't seem like you needed this in order to have an output. But anyways, so this next one is very short, but it's another chapter, so oh. Usually you use a variable as an output when you're using functions to make changes to the variable. What do you mean by that? I'm kind of Do you mean like numbers specifically? All right, I'm gonna close all this down. Well, and we're going. Let me open my notepad. All right. So, chapter 13. I don't know, 14. Is it 13 or 14? 13. And this is function overloading. And we're at 16, 32, 35. All right. So instead of having a separate output variable, you have a function that changes input to be something different. Okay. A function that increments, for example. No reason to do output equals input plus 1 when you can just do input plus plus. Yes. Which is that's another thing. Like I don't. It feels like there's got to be more efficient ways to do all of this. A lot of these things. Stupid example, but you can extrapolate. I believe in you. I mean, I can extrapolate. I have skill issues with this, but generally I feel like I've been understanding what's been going on in the lessons. There have been a few things where I've been like, I don't quite get it. But I mean, nothing that I'm like completely totally lost on, you know? All right. Close this down and go over here. So I haven't set up any of the waiting rooms for later tonight. We are done with our C++ for today. I think tomorrow is also going to be a pretty short one. Yeah, this one's only an hour and 12. Tomorrow is probably going to be even shorter. But I'm gonna go ahead and hop off for now. Get some food, eat, and maybe work a little bit on my Bard's Tale thing. I'm gonna try and get the waiting room set up for the week. We got a few different games for tonight. The C++ will continue around the same time, 3 p.m. Eastern Standard. That is the intent. Tomorrow is also probably going to be a really short day, and but after that, it looks like it's a little bit longer. Might have to split the 14th chapter into 2 streams depending on how long it goes, because it looks like it's an hour long of actual lesson. Yeah, so we'll see. I hope you guys had a good time hanging out and teaching me about this shit. I've been enjoying hanging out with you guys, so we'll be back in the future later. Bye. See you at like 11 p.m. when I do some video gaming. Bye.